Okay, class, how is everybody doing? So we have a lot of people that need to do makeup tests. We have a lot of people that need to do review for their tests because they've been absent. So we are going to do a video today. You have your guided notes that you should have gotten from me out of the tray, or I may have passed them out. I'm not sure how I'm going to do that yet, but you should have your guided notes in front of you, and you're just going to be filling that out as we go. Okay. So we are starting chapter 7 now. We just finished chapter 6. Okay, I've got most of the quizzes graded. Hopefully, we can pass those back on Friday. Okay, but in chapter 7, we're kind of switching gears a little bit now. We've been focused a lot on geometry. Okay, we did all the transformations, reflections, rotations, translations, and dilations. That was all of chapter 5. In chapter 6, we focused a lot on volume, area, surface area of all the different shapes. Okay, that was all of our geometry stuff. And now it's time to switch gears again back to algebra. Okay, so we took a little break from algebra. Now here we are again. Okay. The nice important thing about this is everything that you're going to start with freshman year next year. That's why we save it for the end of the year. Okay, this is like pre-algebra before what you're going to do when you start your freshman year. Okay, so part of getting off to a fast start freshman year is doing well now. All right, so again, as we always do, we're starting in chapter 7:1. Okay, the first part here, and it's a very basic part of this chapter. Okay, it's titled again, you can see it right up there. I've got it on your guided notes, Simplifying Algebraic Expressions. Okay, bear with me with the handwriting. I'm not very good at this yet. Okay, and our goal is to learn to combine like terms in an expression. All right, here we go. I think a lot of this are things that you've already done, so it should turn out to be pretty easy. We should be very familiar. Okay, you've got 3 definitions. The first one is terms, okay? The definition is in an expression, they're separated by plus or minus signs, okay? So we have 4 terms here in this little expression that I have written down below, okay? We've got 7x, that's a term. We've got 5, we've got 3y, and we have 2x. All of those are separated, again, by a plus or a minus sign, okay? All of that right there, those are separate terms. So we call them terms, okay? You'll hear me refer to that a lot. Now, the second definition, like terms, okay? Like terms can be grouped together because they have the same variable raised to the same exponents. Now, Mr. Spottleson is going to be very strict with you, okay? Every time we combine like terms to start out, you are going to circle, star, triangle, whatever you want to do to make sure it stands out that these are like terms. Okay, so looking here, can be grouped together because they have the same variable raised to the same exponents. Well, let's look at 7x. Okay, it has the same variable as 2x over here. And again, they're raised to the same exponent, an exponent of 1. There is no exponent, so that would be considered the same exponent. So we're going to circle our 2x, and we're going to circle our 7x. Okay, those stand out as like terms. Okay, 5, there is nothing that goes with 5. Okay, there's no variable attached with 5. It would have to be like a plus 7 in order to be a like term there. Okay, and there is no plus 7 there to combine. All right. So here we are. Okay, now same thing with 3y. Okay, yes, it has the same exponent as 2x and 7x, but y is different. Okay, if it's not the same variable, they are not like terms. Okay. Moving on, okay? Your last definition that you have there in your guided notes is to simplify. And to simplify an expression, we perform all possible operations, including combining like terms, okay? So if we wanted to simplify this 7x plus 5 minus 3y plus 2x, we've got to combine the 7x and the 2x because we identified those earlier as like terms. So my 7x right there and my 2x right there, if I combine both of those, a 7x and a 2x added together, what are those going to combine to? Those are going to combine to 9x. So a simplified version of this expression would be 9x plus 5 minus 3y. Okay, I've combined now the 7x and the 2y, and I can say that this expression has been simplified. There's no other operations that I can perform there. I can't combine the 9x and the 3y. Those aren't like terms. I can't combine the 5 and the negative 3y. Those aren't like terms. Okay. All right, so let's look at an example here. Okay, you have this example on your paper. The first thing I want you to do is take, maybe if it's a pen or a pencil, whatever you have, if you want to get a highlighter out, that'd be great. Okay, and I want you to circle the like terms. All right, we have 14a. Okay, 14a has the same variable in the same exponent as 5a. Okay, so those are considered like terms. So if I combine a 14a, and again, it's a 14a, the key here is you always want to circle the 14a, and I want to circle the sign in front of it, so negative 5a. If I circle both of those, I can combine those. 14a minus 5, okay, you better not need your calculator for that. 14a minus 5, we're going to get 9a. Those have been simplified. I've combined the like terms. Okay, looking at this next one, okay, and I want you doing this with me, okay? We look at the 7y squared. Is there a term, again, separated by plus or minus, that has the same variable and same exponent? Yep, negative 3y squared. Now, notice again, I'm circling the sign that goes with it. So I have a 7y squared and a negative 3y squared. Let's look for another pair of like terms, okay? If I look here, I've got a positive 8. Is there a like term with that? Yes. Negative 1 has got no variable, so they're like terms, and there's no exponent, so they have the same exponent, which is none. Okay, so 8 and negative 1 would combine. Now, is there anything to combine with this lonesome positive y right here? Well, plus y. Okay, I have a 7y squared, but they don't have the same exponent. So again, this y here does not have an exponent here, while this one does, so I can't combine those. Okay, so now we combine these. All right, so if I combine let me get my pen back here. Okay, if I combine the 7y squared and the negative 3y squared, 7y squared and a negative 3 is going to combine to 4y squared. Okay, and again, there's nothing that I can combine with the y, so it's just plus y. And then I have an 8 and a negative 1. So an 8 and a negative 1, if I combine those, okay, again, if you had $8 and I took 1 away, you're going to be down to plus $7. Okay, so I've now combined those like terms. Okay, so if I'm looking at your paper right now, I should see that you have the like terms either in a different color circled or a different shape around them. However you're going to do it, I need to see your paper like that. Okay, let's go ahead and do another one before I have you practice. Okay, so I've got 4Q. Okay, 4Q. Now, this is where it gets tricky. Okay, Q. It has the same variable. There's no variable with the Q. There's no variable attached with the Q in the 4Q. Okay, so both of these are going to be considered like terms. If I have 4Q, what's the number that's in front of this Q right here? Well, if we don't put any number right there, we put a 1. So that is like 4Q and then negative 1Q. Okay, and if I was to combine those, 4Q and a negative 1Q, what would I have left? I would have a 3Q. Okay. Again, if I'm looking on your paper right now, I need to see you have like terms circled. Okay. Let's go down to B. I have 5C plus 8 minus 4C minus 2 minus C. Okay. So I'm going to use black ink this time so that I can do exactly what I want to see on your paper. Okay. Like terms with 5C. Well, I've got 5C. 8 is not a like term with 5C. But I have negative 4C. They have the same variable. So again, I'm going to circle the negative 4C. Okay, and then the other one would be this negative 1 right here. That's a negative 1C. Again, I'm circling that with the sign. Those are all three like terms. Now, 8 and 2 are also like terms. So again, I'm going to put a triangle around these just so it stands out that I'm combining all like terms. Okay, so now I got to combine everything. Okay, a 5c, a negative 4c, and a negative 1. Now, you don't need to use your calculator, but if it's what you need to do, go ahead. 4c minus, or I'm sorry, 5c minus 4 is going to get me 1c, and then I have a 1c combining with a negative 1. Okay, 5 minus 4 minus 1 is going to completely cancel out and equal 0. So those all cancel out. I don't even need those in my answer. Okay, now I just have an 8 and a negative 2, an 8 and a positive 8 and a negative 2 combined. My answer here when I combine like terms is just going to be 6. Okay, so it's a big equation that looks confusing, but really it's not. All right, moving on. I want you to go ahead and pause this video now, and I want you to do exactly as I did. I want you to circle the like terms, and then if you're just using a pencil, circle and then put a square around like terms. And I want you to make sure you've identified all of the like terms so that I can see that when I check your paper. Okay, pause this video and go work. Okay, you should have paused this video and you should have everything taken care of. So let's go ahead over this. Okay, the first one, I would have circled the 2x. Okay, and I start looking through and I see, oh, 5x is also a like term. So those are going to combine. All right, looking forward, I've got negative 4y. There's nothing, x can't combine with a y, so those aren't like terms. And 3 is kind of all by itself here, so that's not going to be a like term. Okay, so the only like terms you should have had circled here is 2x and plus 5x. Okay, if I combine a 2 and a 5, they're both positive. I'm going to have a 7x. And then I also have to bring down the other parts that weren't like terms. So my answer here is 7x minus 4y plus 3. Okay, looking at this B version here, or letter B, I've got 9d plus 7c. You should have circled the 9d. And then I'm hoping that you notice that, well, C and C can't combine, but I have this negative 4d right here that's also going to combine. So you should have those two circled. And then I have a 7c and a negative 2c, which are like terms. So I hope that you maybe mark those up with something. I'm going to use a square to kind of show that those are like terms. So I'm going to combine my 9d and my negative 4c, and I should have positive 5d. And then I have a 7c and a negative 2c. Again, those are like terms. We've identified that. And a 7 combines with a negative 2. I'm going to have a positive 5c. Okay, so 5d plus 5c. All right, c. I look here. I have an 8g plus c minus 6. Now, is there any like term with 8g? No, there's no other g variable anywhere. Okay. Looking here, I have a plus c. Is there any c variable anywhere? No. And then I have a minus 6. Is there any other just plain number in my expression here? No. So my answer is 8g plus c minus 6. There are no like terms there. So the same exact expression. It's simplified already. Okay. All right. The last thing we want to talk about here is the distributive property, okay? And we've talked about this already. So if I have 2 and then I have x minus 4, okay, and I was to distribute the 2 to both of these, okay? This is a bad example. I don't like that example. Let's change that. All right, so if I have, let's do the one that they use right there. Okay, so if we have 2 and then 3 plus 5, we need to distribute this 2 to the 3 and this 2 to the 5. Okay, so, and when we distribute it, we always multiply. So 2 times 3, because I have to take the 2 to the 3, all right, like that first arrow does right there. 2 times 3 is going to give me 6. And then I also have to distribute the 2 to the 5. So the 2 times the 5 over there is going to be 10. Now I can simplify 6 plus 10, and I get 16. Okay, so let's see how this applies to our expressions here. You should have these on your paper again. Okay, it wants us to simplify 3c plus 7, 3 times c plus 7 minus c. All right, so the first step I want you to do is go ahead and distribute, all right, that 3 to that C. 3 times C, you're just going to have, and again, I just want you copying this down, is going to be 3C. And then if I combine the 3 to the 7, or I distribute it, so I've distributed it there, and now I'm going to distribute it to the 7, the 3 times the 7 is going to get me 21. And then this minus C just kind of hangs out there. Okay, now I'm not done though, because it wants me to simplify it all the way. There's still some simplifying I can do. Okay, 3C is a like term with negative C. Okay, so 3C and negative C can combine. All right, 3C and a negative C, if those combine, I'm going to have 2C plus 21. Okay, because the 21 does not have a like term. Okay. All right, last example before I'll let you start working, okay? We have to distribute the 6 to both the 5 and to the n. Okay, so 6 goes to the 5. Again, when we distribute, we multiply. So 6 to the 5, that 6 times 5 gets us 30. And then I distribute the 6 to the n. So 6 times n is just, again, 6n. Okay, and then this part here just hangs out at the end. All right, since we're simplifying, we've got to check if we've got any like terms. We've got this plus 6n. Again, I'm circling it. You should be doing the same. And I have a negative 2n. Okay, both of those are like terms. If I were to combine those, okay, a 6n and a negative 2n, those are going to combine to 4n. So my answer should be 4n. And then I've got this 30 that doesn't have a like term, but still needs to be in my answer. So 4n plus 30. Okay. Now, I get it. That was a lot of information, okay, and I went through it fairly quickly, okay? The nice thing is this video is going to stay here on Canvas. You can always come back and watch it, okay? But at this time here, if you've watched this video, if your guided notes are filled out, and when I'm checking your guided notes, I want to see that you have circled your like terms everywhere. If I don't see that, then we're going to have a problem. If I don't see you drawing your little arrows over the 3C and over the 3 to the C and over the 3 to the 7, we're going to have a problem. Okay? This may seem very basic, and you may be looking at me. I already know some people that are looking at me like, oh, Mr. Spot, this is so easy. Why do we have to do all these little details? Because eventually it's going to get very long and our problems are going to get very messy, and you're going to need this organization. Okay, so I want you to, on a separate piece of paper, okay, make sure you number it, make sure it looks nice and organized, because I'm going to collect it eventually. And I'd like you to work on page 302, numbers 19 through 39. Only the odds. Don't do the evens. I know there will be 5 of you that'll start doing the evens too. We only have to do the odds. And if you have questions, guess what? Mr. Spottelson is sitting in the room right now and can definitely help you. Okay, go get started.